Okay, section 3.2, we're talking about measures of dispersion. One in particular we're going to talk about is standard deviation. Okay, so if we're talking about standard deviation or measures of dispersion in general, the question we're trying to answer is how spread out, or how much spread do we have, is my data. So we could make a set of axes here. So if we had some data that had a really tall peak around the mean, have something like that, or then we could have some data that comes in and only has a little bit of a peak and goes out that way. So if we're thinking about standard deviation there, then the red would have a small standard deviation, or smaller, and the blue would have a larger standard deviation. So the larger the standard deviation, the more spread out it is. And something else to think about is that if we don't have any spread, if every data value is the same value, then we would have zero standard deviation. Okay, so standard deviation is a number that runs from 0 to as big as you can get. Okay? And then there's one other thing we need to talk about here. We're mostly going to deal with standard deviation, but you could deal with something similar called variance. You'll see that sometimes there's times when one is a little bit better than the other to talk about, but the two are related. And so if we are talking about variance, it's just the standard deviation squared. Or you could say that the square root of variance is standard deviation. So if you need to get back and forth from variance to standard deviation, you're going from standard deviation and you want variance, you square it. If you have variance and you want standard deviation, you take the square root. Okay? And then one other little table here to make, because we do have two variables we're dealing with, two new symbols. Okay? Because sometimes we're dealing with sample data, sometimes we're dealing with population data. Okay, and then sometimes we will be, we'll want variance. But most of the time in this class we'll want standard deviation. Okay, but here are our tables. So if we have sample variance, okay, the symbol for that is S squared. And remind us that that's the square, the standard deviation. Or if we have sample standard deviation, the only difference is we take the square root, so we just get S. If we're talking about population values, then for variance, our symbol is a lowercase sigma, Greek letter sigma squared. And if we're talking about population standard deviation, we've got just the lowercase Greek letter sigma. Okay, so standard deviation is the one without the square. S is for sample. Sigma is for population values. Okay, so kind of a lot to keep up with here. But the biggest hurdle in this section is going to be figuring out how to do standard deviation on your calculator. Okay? You do not have to ever worry about the formula in this class, okay? Because the formula is really long if you have very many data values. So instead, we have calculators with statistical functions we're supposed to. So those will handle standard deviation for us. Okay, we won't have to deal with the formula directly. Okay, so let's look at a problem here. Okay, this one says calculate the range, population variance, and population standard deviation for the following data set. If necessary, round to one more decimal place than the larger number of decimal places in the given data. Okay, so we have three calculations we want to do here. The first one is the range. This is the easiest one. To get the range of a data set, we just take the largest data value minus the smallest. So let's see here, the largest data value I see is 17, and the smallest is 6. So So our range is 11. Okay. And then if I'm doing this problem, the next thing I'm going to go to is I'm going to go to standard deviation. And it says we want population standard deviation. So this is going to be sigma. In your calculator, a lot of times it'll be called sigma x. That'll be what you're looking for there. So I have posted 4 different videos on Canvas showing you some different calculators, how to do standard deviation. If your calculator is not on that list, just go to YouTube, type in your calculator model, and then standard deviation, and hit the search, and a video is pretty much guaranteed to come up. And so pretty much any calculator, you're going to be able to figure out how to do it off of YouTube. Okay? So next, how to find my population standard deviation. So I'm going to take my calculator, put the data in my calculator, and then get my number out. So I'm going to pause and then I'll be right back. Okay, so in my calculator calls this population standard deviation. Mine calls it sigma x. And what I'm getting is 3.796 something. Okay, but we want to round to one more place than we had in the data. We did not have any decimal places or any digits after the decimal in our data. That means we're going to round to 1 decimal place. So this one we would call 3.8. Okay. And then the next thing we want population variance. Okay. And most of your calculators are not going to give this one to you. Okay, so what you have to do is you have to take the number from the last time before you rounded and just take 4 or 5 digits, okay, and square that to get the variance. So hit the square button here, and I got 14.41, but we can round that to 1 decimal place, so 14.4. So again, most of the work on that goes in your calculator. You just need to figure out how to use your particular model calculator for these. Okay? Look at another one. So this one gives us the standard deviations of 1 year of daily stock closing prices for these 2 stocks. And it says which company would give Donna a stable long-term investment. Okay, so here the stock price is going to be more stable. It varies less, okay, if it has a smaller standard deviation. So since the Azure travel company has the smaller standard deviation, that's going to be better for a stable long-term investment. Smaller standard deviation means it's less risk, okay, less risky. The larger standard deviation would be better for trying to get money in a hurry, okay, but it's also more risky. So on that one, we would say the Azure travel company because it has a smaller standard deviation. Okay, one more here. Look at this one. So this one says calculate the sample standard deviation, round to 1 more decimal place than in the data. Okay, so the big thing to think about here is it says we want the sample standard deviation. And I'm making a big deal out of that because if you calculate the sample standard deviation and population standard deviation for the same data, you'll get 2 different numbers. So we want sample standard deviation. So what we're looking for here is S, or your calculator is probably going to call it SX. And so that's really important to know which one you're looking for. So I'm going to punch this data into my calculator. Okay, I'll be right back after I do that. Okay, so on mine for sample standard deviation, my calculator is giving me 0.9675, on and on and on. So here we want to round to 1 more decimal place than we had in the data. So in our original data, we had 1 digit past the decimal place. So in our answer, we're going to leave 2 digits past the decimal place. So we would have 0.97. It would be our standard deviation. Okay. And by the way, the units would be whatever units you had in your data. So degrees Fahrenheit would be our units here. Okay, so check out those calculator videos and make sure you can do standard deviation on your calculator.